Alright class, today we're going to be discussing variables. Uh, what they are, how they work, how we would set them up in NetBeans or any program. So, first and foremost, let's answer the question, what is a variable? A variable is, you can kind of liken it to a box or a holder, something that can hold some information for you. So far at this point, every program we've created, you can print things, you can basically, well, but that's pretty much it. Just print things on the screen. We could do some math, uh, and that's pretty much all. Now, every time I run the program, it will pretty much be exactly the same every single time. I simply have to just, if I want it to be different, go in and change all the print statements and everything, right? Now, what a variable allows you to do is store information. Uh, so instead of just printing, hello Bob, what's going on? You can put a variable in there, and that Bob could be something different each time you run the program. Uh, it also allows us to, do a little math or save some information. A good example of this would be, let's say you're playing a game and you'd like to save your progress. Well, that has to be saved somehow, somewhere. And a lot of that information can be saved and stored in variables. It's almost like a little cubby hole or a little locker, a place for you to put a particular thing. Now, a variable allows you to save one specific type of information. So I could save, let's say, a number or some text in a variable. Now, in Java, I have to directly tell it specifically what type of variable I want to use. I have to give it a name, and then we can put things in it and use it. So let's get a good idea of how that works first. So I'm just going to make a project. And again, I would encourage you, whatever the date happens to be, to go ahead and put the date up there. And intro variables is what I'm going to call this. Uh, and hopefully at this point, we've done this a couple of times, you're starting to get a little more used to it. Naming it, making sure it's saved in the right place, and erasing that little second iteration there. Finish. And voila. And another thing you should hopefully be getting used to is just setting this up. I usually erase the top comments, and then I give myself a couple of spaces here in the main. Make a little comment at the bottom, and again, I would do that, just make it a habit. It may not be that helpful at this particular point in time, if you're watching this video, but trust me, making these little comments at the end of the braces will save you a ton of time later on, particularly if you do it for every single one. Because we're going to have more of these braces, and this is just a good, easy way to mark where that brace starts, where that brace ends. So, uh, first off, quick reminder, just about everything we write has to go between these two braces, where it says public static void main and where I've put this end main at. Now, if I try to write something outside of this, if it's the right thing, it can work, but most of our programming code is going to have to go between this. There are a couple of instances like we saw before with the G-option pane, where I have to import something, and that goes at the top. If I want to do any actual executable code, it's got to go in this main. There are a couple instances where we're going to go outside the main, but that's later. But for now, everything needs to go here. If I start writing print statements outside of this, notice it didn't even allow me to do the little shortcut. No, that's not allowed. Class interface or enum expected. If I try to put this above, still same thing. It has to be within this main here, and then it's perfectly fine. So let's talk about variables. Now there are several variables we're going to be able to use. Now I'll go down the list and show you what each one does, a couple of comments. Then a later program we'll actually play around with them a little bit. This will just be a list of how to define them. Now, before you use a variable, you have to do what's called defining it, declaring it. You have to let Java know that you want this thing made and what it's going to be. So, for example, one of the most common variables is an int, integer. So I use this int and notice it became blue. I do a little space and then I have to give it a name. Put this down a little bit. Now I'll just call it number1, or just number, equals. And then I can put a number, let's say 8. And I end with a semicolon. This, once it runs, it's going to tell Java that I want an integer, and it's going to be called number. And I'm going to put an 8 in this. Now later on, I can change this to 20 or 50 or whatever number I want it to be. But for now, it's going to be 8. I don't actually have to put anything in it technically. For right now, I can just define it and then put something in it later if I need to. But how this works is I define basically what it is I want, what type of variable it is, and then I have to give it a name. Then I can put an equals and then whatever item is going to be plugged into that variable. Now for the rest of this program, number is going to be 8. So if I were to print the number is, I can directly say number and see how it lines up like this, or lights up rather. Now if I were to write in, let's say number 1 here, you're going to get a red line. And it's going to tell me that it can't find symbol because it doesn't know what number 1 is. I define something called number, so when the program runs, it knows what that is. It sets a little space for an integer, and I can plug whatever numbers in it I want. Now, I run it, and we see the number is 8 because that's what I set it to. So an integer is a whole number. 1, 2, 3, 4, -5, -6, -7. And it can go up to, I always forget the specific number, but it's 2.3 billion or something like that, 2 point something billion. That's as big as it goes. Anything bigger than that, either in negative or positive spectrum, it will crash. But usually 2 billion is more than enough anyway. But if you want to look real quick, a 32-bit int is what this is, and it's, what is it, 2 to the 32, I think, power. And that's how big this gets, if anyone's interested in that. Basically, it's 2 to the 32 power. Let's see if I can do it. Whoop, that's not the one I wanted. Let's see, 2 times 2 times 2. That's to the third. 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 30, 31. There it was. Whoop, I gotta go back. Right here. 2.147 billion would be what it is. Because 0 is our first one. So basically, that is as big as a integer can be, negative or positive. So if I were to come in here and just write an obscene, a large number, it will crash and tell you that's too big. But I could use a reasonable number. Now, I can also change this. I can say number equals 9001. And what is it going to print? Well, 9001. And the reason it prints 9001 is because it was 8, and notice the little yellow line there. This assigned value is never used. Well, it's 8, and then I change it immediately without using it. So that's just, a yellow is kind of a warning. If you see red, that is an error. So I can change it to whatever I want. That's perfectly allowed. Now I cannot do int a second time. Uh, Notice it says variable numbers already defined. Well, there's already a number. Now I could do number 1, and I could have a second variable, but I can't use the same name. You only have to declare it with the int one time, and then you can just use it for the rest of the program. Plug things into it, change it, whatever you want. Now, other variables you're going to see. There's double, and this is going to be, let's just say 3.14. Basically, a double is a number, but it allows decimal places. Now, I can go upwards to, let's say, 14, I think, decimal places, if I remember correctly. Another option would be a float, which is actually a little bit less than that, but float number 2. And that's going to be like 3.14f. And I have to have the f there. There we go, back up. And I have to have the f there for floats. Now, honestly, in this class, the thing that we will use the most will be either integers or doubles. Doubles will typically be what we use for any kind of math. Now, floats, the big difference between these two, other than the f, is I can still do math on both of these, but this only holds like upwards to like 7 decimal places. This holds double that amount, which is why it's called a double. Where that matters, maybe if we were doing some really intricate programming where every little byte of information matters, like, every little, we need to conserve as much RAM as possible, we might prefer floats to doubles for things like that. A good example of that would probably be, let's say if you were writing a program for like a handheld device, it has very limited memory. If you don't need a lot of decimal places, you'd probably prefer to use a float because it uses less memory. So this allows for decimals. Now you could also make this just 3, like that. And what you'll end up getting, actually, let's go ahead and just put a couple of things here. Now if you want to print a variable after a string, we put that little plus there. And that allows us to print that variable. So if I do a 3, for example, you'll see it ends up printing 3.0. So even though this is technically an integer, it converts it. It basically upscales it. Now I cannot do this the other way. I can't put 8.14 into a number. It'll tell you, this particular error. Incompatible types possible, lossy conversion from double to int. It's saying this is an integer, that's a double, it doesn't fit. I guess the realistic example of this is you can put something smaller into a larger slot, but not something larger into a smaller slot. So basically, the integer is smaller, I can't put the larger double into it. But the other way around, I can put this smaller item into a double, and it would work. Now, and if I printed the float, just so you can see what that is, notice it doesn't show the f, but when you're actually defining it and stuff, you do have to put the f there. If I take the f off, it's going to tell me it's a double and complain. But again, we're not going to use floats that much in this particular class. Now there is also a couple of others. There is Byte, which we're never going to use. And that's like really small things. There's also short, which is basically, if I remember correctly, it allows to like is it 256 or 1000 or something? There's almost really no reason to even use that, and we're never going to use it. But if we wrote short, you'll see it'll turn blue. And things that turn blue is basically means it's a reserved word. It means I can't use float as a name, for example. If I come up here and I say float, float, not to be confused with it, the movie or something. Float's a reserved word. I can't use it to name stuff. Now I could say float 1. That's not reserved, but float itself is. And short, really small numbers. Now long, however, is actually particularly useful. And the reason for that is, this allows decimal places. I'll just put a little comment there, like 7 decimals. And this is double the decimals up there. Long is for really big numbers. Notice how our integer only holds like 2.14 billion. Well, a long allows for an even larger number than that. So a good example of this is it system.currentTime_millis? There it is. Now, what this particular thing is, just so you know, I believe it's 1960, or is it 1970? But basically, this is how many milliseconds have occurred since January 1st, like 1970 or 60. Let me see here. Current time millis. I'm just going to do a quick little find, and we'll see. Whoop. Here we go. Let's see. Current time millis. But basically, it finds how many milliseconds have occurred between now and that date. It's 1970. There it is. Knew it was one of those two. So, basically what this means is, if I run it and print it, you'll see milliseconds. I'll just put number 3 there. Now let's take a look at how big this number is. There we go. That's how many milliseconds have occurred. Now, a millisecond is 1,000th of a second. And this is 50 something odd years ago, right? And you think, well, shouldn't that be bigger? Well, there's 60 seconds in a minute, 60 minutes in an hour. You do your math. You can figure out how many milliseconds there are in a given day or year or whatever. Now, this is also how time is calculated, like in servers and on games and stuff like that. If you ever played anything where it told you your ping, that's how many milliseconds it takes for your command to hit the server and come back. If you're playing a game that really depends on you having good internet, and your ping says it's 3,000, that means you have 3 whole seconds by the time you click, go get that guy. 1, 2, 3, before your command actually gets executed and the guy moves. Horribly frustrating if you're doing any online games like that. But it's also used in animation. If I want to know how many milliseconds have passed so I can play the next frame of animation, that's where this particular variable is pretty useful. And you can see if I run it again, we'll get a new number. Every millisecond, this changes. And it just keeps getting bigger and bigger and bigger. And this is what longs are used for. So let's just see, that's 100,000, 100 million, so we're somewhere in the billions. So we're pretty well up there, size-wise, I would say. But that's typically where you would see a long used. And it's used for, like I said, animation, getting the time, timers and things like that, as well as online pings and whatnot. Now, we covered int, we covered double, float, long. Those are basically your numbers. So the next item would be character. I'll just call it letter. Now this is denoted with little apostrophes, and I can put a letter in there. Now I can't put more than one. A character, or some people will pronounce it char. Me personally, it's short for character, so I always call it a char. I don't think it matters that much, but uh, a character allows for one letter. Now, alternatively, I could also put in 1, 5. That is a character. I could also put in, let's see, boop, the @ sign, or the pound sign, also known as the octothorpe, if you ever want to Google just to say, oh, I know a new name for the hashtag pound sign. It's called the octothorpe. Google it, look it up. But as long as there's just one character, I can put anything I want in here. Now, it doesn't necessarily have to be a letter. It can be a symbol, question mark. As long as it's not 2. Any 1 is fine. In fact, there's a lot of tricks you can do with something called the Ascii table. So this is basically one letter. Oh, and long is big honking numbers. There you go. That's the technical definition. Big honking numbers. Now I can print that one letter. And this is used a little less than other things. It depends on what you're trying to do. I could read text one letter at a time, for example. If I was reading through a password, perhaps, I might look at that one letter at a time. If I wanted to look at more than one letter, I would use what's called a string. And this is with the double quotes. Words are nice. Okay. This has to have quotes. This up here is a single apostrophe. If I put a quote around it, it will, of course, not be happy with it. String can't be converted to character. So I can make, I believe, a string allows up to 2.14 million letters, actually. Not that you'd probably write that many, given that like a 500-page book probably has like 50,000 in it. You'd be talking about a lot of books. But this is typically used for, what's your name? Save your name in there, first name, last name. Maybe a sentence or two, like in a game where it responds depending on what you pick. It pulls a string out of one of the variables or one of the files and displays it on the screen. That's what this would be typically be used for. Now, of course, I can print that, just like I can print the letter. In this case, I'm just going to print word. And it'll print that whole line, just like that. And we can, of course, put those little /n in the middle of that. And it'll treat that just as part of the string and actually press enter and move it down. Also, there is /t, which is basically a tab. Doot, for those who don't know how to use that yet. Those are the two that I use the most. There are a couple of others, but those are the two that are really the most useful. Now, we've got our string, which is just for words and sentences. Now, last but not least is the Boolean. Now, this is either going to be true or false. Now, this is useful for flags in a program. If somebody has done something, check it to true. If this box is checked, it's true. If the person has a key to the door, the door will open, set it to true. That sort of thing. If you said yes to this particular event, this happens. If you said no, this happens. That's what these Booleans are used for. They're also used for if statements and loops and other things later on. But there's only two answers to this, and that is either true or false. Boolean being what it's called, you see that's fairly long, and I can name it whatever I want. And it's going to be true or false. Now, one thing you may have noticed in my list here is integer, double, float, long, character, string, Boolean, right? String looks a little different than the rest of them, doesn't it? It's not colored in blue. And that's because of how Java kind of treats a string. A string, what these particular things are called primitives, meaning that's kind of the smallest way Java can declare what those things are. So a letter, true, false, a number, that sort of thing. A string, however, is actually a bunch of letters combined. So it treats it as this kind of array of letters. And the reason they do it this way, and it does have to be a capital S, lowercase s is not very happy with that. If I say word dot, notice this huge list of things comes up. If I can get my screen over there properly. There we go. We've got converting to an array, changing it to lowercase to uppercase. Starts with this. We can get a subsequence. We can get a substring. We can replace letters with new letters. We can get the length of the string. We can see if it is empty, if it has something in it, if it has a particular string in it. We can compare it to other strings. There's all kinds of little doodads in here that are not in these other things. If I were to say, for example, letter dot, nothing happens. If I were to say, number one dot, nothing happens. But word, because it's kind of this higher level storage thing, they've got a whole bunch of built-in functions and methods that allow me to do a little bit more stuff with it, which is very, very useful. Instead of me having to do all this by hand or maybe go into it one character at a time, which I could do. As a matter of fact, word dot char at allows me to actually get a character at a particular location. But that's basically what you can do with this. Because it's a little different, you can do a lot more with it. Now for us right now, we're just worried about putting something into it. That's it. So we've got Boolean, we got a string, we got a character. Long, we talked briefly about short and byte, which again, we're not really going to be using. If you want to Google a little bit about those, you can. Short is just kind of like a really small number range. There's honestly really no reason to use it. Byte, really, really small, low-level stuff. Most people wouldn't be writing a program that low level, so you don't really need to use it. Float, double, int. Those are the major ones you're going to be seeing. Now, if you have any questions or problems or anything like that, just let me know. We're going to get a little more into this, how we, add and do stuff with these things, displaying these things in different ways, that sort of thing here in the next project.